Your arm is S. Okay, I'm going to get the pro. 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector are good. Ag thought.
I'm going to point out the thrust because it looks like
Pitch over.
we can
Roger,
see
you have good thrust.
it's plastic.
Okay, 30 seconds. Good. Ag thought.
We see the reflection there.
Pitch over. Roger, you have good thrust.
It looks like thrust.
Okay, 30 seconds. 308 your number. Okay, coming through 1500.
Because what's really reflective off the bottom there?
Pitch over.
What's real, what's...
Roger, you have good thrust.
Right?
One more stage. Push. Engine arm is S. Okay, I'm going to get the pro. 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector good. Ag thought. Pitch over. Roger, you have good thrust.
That looks like thrust, huh?
Altitude, velocity light. 3.5 down, 220 feet. 11 forward, coming down nicely, 200 feet. 4.5 down, 5.5 down. 100 feet, 3.5 down, 9 forward. Okay, 75 feet. Guys looking good, down a half. 6 forward. 60 seconds. Lights on, forward. Forward. 40 feet down, 2.5. Picking up some dust. Straight shadow. 4 forward, drifting to the right a little. 30 seconds forward. Contact light. Okay, engine stop.
In the footage of Apollo lunar modules leaving the moon, the ascent stage is not seen burning a plume like we see a rocket does leaving the Earth. Therefore, the idea goes, if there's no plume, there is no real rocket, therefore we never really landed. It was just a model being raised.
Where'd her hands go? Where'd her hands go? Do you notice that she didn't show the plume?
Is not seen burning a plume like we see a rocket does leaving the Earth. Therefore, the idea goes, if there's no plume, there is no real rocket, therefore
they cut it out.
we never really landed. It was just a model being raised off a simulated moon. Well, that's not true, and it has to do with the fuel that the lunar module burned. When you think about a rocket that's launching off the Earth with a huge plume of flame, you're thinking of something like the Saturn V, something that burned a mixture of kerosene and liquid oxygen to get off the ground. But the lunar module didn't burn the same combination of fuel and oxidizer. Instead, it used hypergolic fuels, or hypergols. Hypergols burn on contact. They don't need an ignition source, which means all you have to do is open a valve, let the two mix, and boom, you're off. Which is great with spaceflight because that's one less thing to worry about. Another characteristic of hypergols is that they typically burn clear. This is the case of the lunar module. Both the lunar module ascent stage and descent stage used a mix of aerosine 50 and dinitrogen tetroxide, a fuel and an oxidizer that burn on contact with a characteristic clear flame. A clear flame of the ascent stage, though it is a secondary reason to the fuel mixture. On Earth, our atmospheric pressure means that we see the exhaust of a rocket as a column. It doesn't really spread out much because the pressure of the air keeps it contained. That's not the case on the moon where there is no atmosphere. You wouldn't see it the same as you do on Earth. And I'll throw in the fact that the cameras weren't exactly high-definition TV cameras that showed it. So even if you could see a very tiny bit of the flame leaving the moon, you probably wouldn't see it on that not-so-great TV footage.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector good. Ag thought. Pitch over. Roger, you have good thrust. Pitch over. Roger, you have good thrust.
What?
Pitch over. Roger, you have good thrust.
Yeah, good place. It sounds like thrust. And
Okay.
can you hear it in the microphones too? Like nothing, nothing, nothing.
Good over. Good thrust. Okay, 30 seconds. 308 your number. Okay, coming through 1,500 feet, and H-dot looks good.
That looks like thrust, huh? That looked like exhaust, huh? Notice how there's like there's no dust. None. And it's like, you know how easily they could have debunked, they could have like proven things if there was actually some footprints in the soil. But yeah, like, and it doesn't look like freaking things were blown away. Not for the size of that bell, right? I mean, that's a pretty big exhaust. And that Mylar, gold Mylar, like, hold on a second.
99, proceeded. 3, 2, 1. Ignition. Right away, Houston. Vector grid. Ag thought.
Hold on. So, alright, am I just being retarded? Okay, so there's the engine, right? I mean, because... Well, that's the damn thing, is like, that's where it separates, because that stays down below. And it's like, where's the engines on that thing? Okay, well, you see, his boots are dirty. But, like, guiding that thing with one thruster primarily. How's this thing?
If you tilted too far, you could just fall out of the sky. You really had to be on your toes.
In 1968, Neil Armstrong prepares for his 21st flight in the lunar lander trainer.
Notice,
The first 20 went well.
So, that thing is... He's not even in the same position that he would be in the, when he landed the thing. Not to mention, like, look. Look at that, right?
But this one suffers a rare malfunction.
All of a sudden, it lurched, kind of tipped over on one side.
With no time to spare, he was really close to a fatal accident. He was able to eject.
We started building prototypes. This one had 5 legs. Our astronauts will want to see outside, so let's make a cockpit with some windows. The final design has only 4 legs, and the windows are much smaller to save weight. It was about 23 feet tall. The LEM was designed and built in Bethpage, New York by the Grumman Corporation. It took to the surface of the moon. It was launched aboard the Saturn V rocket, and then went to the moon along with the service module and command module. These three parts together are what we call the Apollo spacecraft. The LEM was the only part that goes down to the surface of the moon. It was the first spacecraft designed to only operate in the vacuum of space. So for example, the command module needed to be really aerodynamic for the launch through the Earth's atmosphere. The LEM wasn't exposed until it was in outer space. Since there's no air up here, the outline really doesn't matter. This is part of why you get a spacecraft that looks unlike anything we've seen before. Were planned, but were cancelled due to budget cuts. The LEM was split up into two parts, the ascent stage and the descent stage. For the landing, both parts went to the surface of the moon. When it's time to leave, only the ascent stage leaves the surface, which means that each of the Apollo moon landings left behind a descent stage. Let's zoom in for a closer look. There were 4 legs attached to the side. These were originally in the retracted position so that the LEM would fit into the Saturn V for launch. Then, once they are getting ready to land, the legs are extended. 3 of the legs contained a contact-sensing probe, which told the astronauts that they were close enough to the surface to shut off the descent engine. This leg has the ladder, which the astronauts can climb down. On the left side of the ladder, there's a container which holds the American flag. The shape of the descent stage is somewhat of an octagon. Here's what the structure looks like underneath. Inside, there were 5 box-shaped compartments. The center one contained the descent engine which was used for landing on the moon. In order to light this engine up, we'll need 2 oxidizer tanks and 2 fuel tanks. They both feed right into the engine. This gives us the propulsion we'll need to safely land on the moon. These outer areas are where they stored more equipment. They called them quadrants, so this was quadrant 1, 2, 3, and 4. Quadrant 1 was for general storage. For the last 3 Apollo missions, there was the lunar roving vehicle packed inside of here. Once on the surface, it was unpacked and ready for use. This allowed them to explore much last 3 Apollo missions, there was the lunar roving vehicle packed inside of here. Once on the surface, it was unpacked and ready for use. This allowed them to explore.
That's pretty damn convenient in size, huh?
Or much further from the lunar module. Quadrant 2 contained a water tank. It was unpacked and ready for use. This allowed them to explore much further from the lunar module.
Where do those sheets and where'd everything else come from?
Quadrant 2 contained a water tank, and then below here was the Apollo Lunar Surface Experiments Package, or ALSEP, which basically contains several science experiments for them to perform. Quadrant 3 had another helium tank, oxygen tank, and on a few missions it carried retroreflectors, which is a special kind of mirror. They were left behind on the surface of the moon, and they allow scientists, even today, to bounce laser light from the Earth to the moon and back. Quadrant 4 contained the Modularized Equipment Stowage Assembly, or MESA. And if you've ever wondered how we recorded those first few steps on the moon, there's a camera here that points right towards the ladder. The landing legs were attached on the main structure. The covering on the outside was made out of mylar.
They were trying to save weight, but they decided to put a camera right there, huh?
Which looks like gold tinfoil. They used it because it was lightweight, and it made sure that the inside temperature didn't get too hot or too cold. This is the platform that leads to the ladder, and these are the plume deflectors. They protected the spacecraft from the thrusters on the ascent stage. We'll talk about that later in the video. Before we look at the ascent stage, I want to thank Audible for sponsoring today's video.
Oops.
If we remove the cover, you can see some of the machinery underneath. Let's start with the main structure. This is the crew compartment, the midsection, and the aft equipment bay. Both the crew compartment and the midsection were normally pressurized, which means that they can safely take off their spacesuits. The crew compartment didn't have a lot of room. Controls were mostly in the front, and then there's 2 windows to look outside at the surface of the moon. The commander was on the left and the LEM pilot was on the right. Remember that the 3rd astronaut was still orbiting the moon in the CSM. After landing, this hatch is for the astronauts to leave the cabin and start their climb down the ladder. In the midsection, you'll find more equipment and this cover, which protected the ascent engine, and of course the tunnel to dock with the command module, once back in lunar orbit. The aft equipment bay has more oxygen and helium tanks, as well as other electronics for the LEM. There's a fuel tank here and a smaller oxidizer tank here. This is the reason that we have these bulges on the side here. Both of these tanks feed right into the ascent engine, which was used to blast off the surface of the moon. On the outside is the Reaction Control System, or RCS. It's an arrangement of 16 thrusters in groups of 4. It was powered by fuel and oxidizer tanks on the side here. During the flight, these thrusters could be used to maneuver the LEM. The plume deflectors help redirect the exhaust to protect the descent stage. On the outside were several antennas to let them communicate with mission control back on Earth. So much effort went into building each lunar module. What's sad here is that they could only be used once. Most of the descent...
Oh, blast it. Damn, I think I keep on messing this thing up.
Mission arm is out. Okay, I'm gonna get the...
But yeah, friggin'... I don't know if I said it, friggin', but yeah, there's no way the Jeep got on there. Yeah,
Oh.
just go on.
One, ignition. Right away, Houston.
I don't really, see anything. I don't really see a thruster there.
Extra good. Ag side. Pitch over. I hear you have good thrust.
But I definitely see it there.
Deck's on, Mark. That max acceleration? No. Man, you are really bouncing. Is he on the ground at all? 10 kilometers. Huh? He's got about 2 wheels on the ground. He's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. Okay, the deck is running. Man, I'll tell you, Andy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns. Hey, that was a good stop. Those wheels just locked. Mark off. Okay. Do you want to do it one more time? Yeah. About a minute, 5 seconds that time. Mark on. Okay, you could have gone the other way. Go ahead. There's the big craters there, though, aren't they? Yeah, I know. Yeah. One of those holes. They want 4 minutes for it, John. Well, it's 1 minute and 5. Maybe you can do it twice more. Surely. Okay, turn sharp. I have no desire to turn sharp. Okay, here's a Sharpie. Hey, that's great. Man, those things, when those wheels really dig in, John, when you turn is when you get the rooster tail. The suspension system on that thing is fantastic.
That sounds good. We sound like we've probably got enough of the Grand Prix. We're willing to let you go on from here. Call that a Grand Prix.
Okay. Man, that was all 4 wheels off the ground there. Okay, max stop. Okay, I don't want to do that. Okay, excuse me. That's a no-no. Okay, deck off.
I don't know.
That max acceleration? No. Man, you are really bouncing.
Is he on the ground at all?
10 kilometers. Huh? He's got about 2 wheels on the ground. He's a big rooster tail out of all 4 wheels.
And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. Hey, the deck is running. Man, I'll tell you, Andy's never seen a driver like this. Hey, when he hits the craters and starts bouncing, it's when he gets his roots.
Let's show this again.
Man, you're really bouncing.
I think this looks a little bit better.
How are you? No. Man, you're really bouncing. Is he on the ground at all? 10 kilometers. Huh? He's got about 2 wheels on the ground. It's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. Hey, the deck is running. Man, I'll tell you, Andy's never seen a driver like this. Hey, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes a sharp turn. Hey, that was a good stop. Those wheels just slide. Mark off. Okay. Hey, you want to do
To the moon. The lunar module had limited storage space. Engineers finally came up with an ingenious idea: a collapsible car. It fits inside a segment of the lunar module and unfolds with a lanyard. To keep astronauts from bouncing off, NASA installs tow holes and a seatbelt. Engineers also literally reinvent the wheel.
There's no exact knowledge about.
Ever had anybody ask, can you see the flag on the moon? Sure, at almost every public astronomy event.
Oh wow, we can see the moon, or the flag on the moon, right? NASA Night Sky Network.
American surveyor missions are all still there, silently looking back. Unless, of course, you're a NASA non-believer. So why can't we see these from Earth? Why can't we train our best telescopes onto the moon's surface and see them exactly where we left them the best part of 50 years ago? Well, there's a bit of a problem. And that is that the moon is 384,000 kilometers or 238,000 miles away. And the landers and all the things left behind are just a few meters across. To give you an idea of just how difficult this problem is, it's like looking for an object the size of a coin from 1,000 miles away, or the equivalent of from New York to Florida. So you're going to need a pretty serious telescope. One telescope which springs to mind is the Hubble Space Telescope. After all, if it can see galaxies billions of light years away, then it should be able to see the Apollo landers easily, shouldn't it? Well, as with many things to do with space, it's not that simple. Yes, the Hubble Space Telescope was indeed designed to look at very faint objects at astronomical distances, but those objects are clusters of galaxies trillions of miles across. It was just not designed to take high-resolution images of small objects.
Was looking for an aircraft that could improve their aerial reconnaissance and couldn't be reached by Soviet air defenses. The Lockheed U-2 was first proposed in 1953 as a spy plane that could fly day or night through any weather conditions at a high altitude of almost 70,000 feet. The aircraft flew for the first time in 1955, and ever since, it has been part of some of the major conflicts involving the U.S. It's been 60 years since its first flight, and the updated U-2 remains in frontline service. It's endured the test of time thanks to the modern infrared and electro-optical devices it carries, and its ability to change surveillance targets on short notice. But its wet film cameras are even more astounding. Located at the belly of the airplane and as big as a film projector, they can distinguish objects as close to 8 inches to as far as 70,000 feet apart. They also provide high-resolution images that allow the pilot to see anything 250 miles in any direction. Major Travis Lefty Patterson, a U-2 pilot, has said the fidelity of the camera is so good that, quote, if somebody is holding a newspaper out, you can probably read the headlines. The cameras and satellite sensors on the plane have also come in handy for humanitarian missions. U-2 aircraft provided imagery of floodwaters after Hurricane Katrina struck New Orleans in 2005. It also documented the aftermath of the massive 2010 earthquake in Haiti. To this day, a 30-plane fleet is flown by U.S. Air Force pilots for combat missions over Afghanistan, Syria, and Iraq. There, it has been used to hunt improvised explosive devices hiding in roadsides and helicopter landing areas. This allowed the Marines to detonate nearly 150 mines in Afghanistan. Thanks to the U-2's high-resolution photographs, they were also able to track insurgent footpaths and identify the spots where they are most vulnerable. An aircraft for science. The U-2 has been very valuable for scientific research. A version of the plane, the ER-2, has been operated by NASA's Airborne Science Program since 1971. In 1998, it set a world record for reaching an altitude of 67,190 feet in horizontal flight. Currently, 2 ER-2s are used by NASA as mobile laboratories, thanks to their ability to fly into the lower stratosphere at subsonic speeds. They've made notable contributions to science with digital multispectral imagery for global climate change research and aerial photography. Through its missions with NASA, the ER-2 helped discover that human-made chemical compounds provoked ozone depletions over the Antarctic region. The aircraft has also been invaluable for studying hurricanes, tracking their intensification and landfall impacts. The ER-2s have flown over violent storms like Category 5 Hurricane Emily. From those missions, it's collected data that allows NASA to better understand the formations of powerful storms. The ER-2s are also used to test airborne versions of satellite sensors. Such sensors are used for studying the effects that aerosols, fine particles suspended in the atmosphere on the Earth, have on water and air quality. At nearly 70,000
Chemtrails? Man, I'm just going through them all right now, aren't I? Oops. I didn't mean to do that. Friggin', let's see. Global hotspots are known in detail. This camera is also known to provide positive proof of existence of Soviet missiles in Cuba. Shooting through 7 glass-encased windows in the belly of U-2, the B camera recorded everything along a 3,500 kilometer, 2,700 mile course up to 125 miles wide. And it could provide up to 4,000 pairs of stereoscopic photographs. 36-inch lens resolved features as small as 0.75 meters, 2.5 feet from an altitude of 65,000 feet. The Central Intelligence Agency displayed this camera in 1972 Cuban Missile Crisis Exhibit CIA headquarters, and then 1977. So,
This image was taken 17,500 feet above Quantico, Virginia, and covers 15 square miles.
This whole image is at a very, very fine resolution. So if we wanted to know what is going on in any spot along this image, say near this building at this intersection, we can generate a moving image that shows what's going on in the area.
Simply by touching the screen, Antoniades has opened up a window showing a detailed area, while still maintaining the broader context.
And everything that is a moving object is being automatically tracked. The color boxes represent that the computer has recognized the moving objects. You can see individuals crossing the street. You can see individuals walking in parking lots. There's actually enough resolution to be able to see the people waving their arms or walking around, what kind of clothes they wear.
But yeah, we can't see the lunar module. We can't see the flags from the moon. And that's what I'm saying is there's a lot of disinfo agents out there. You know, your favorite YouTuber might actually be part of their damn government. They recruit from within.
You could pick the location of where you produce these images anywhere in the entire field of view.
Antoniades can open up to 65 windows at once and can see objects as small as 6 inches on the ground.
From even 17,500 feet, the white thing that you see flying around is a bird.
Yeah. Yeah, but we can't see things on the moon.
This image.
Type in quickmap.lrock.asu.edu and you'll come up with this beautiful picture of the moon. The first landing site I'm going to take you to is the Apollo 11 landing site, which occurred on July 20th, 1969. If you look at these 3, what they call dark seas, as in not letter C, but SEA, as in ocean sea. The top one here is called the Sea of Serenity. The middle one here is called the Sea of Tranquility, and the one down here is called the Sea of Fertility. It was here in the Sea of Tranquility that Apollo 11 landed, and Neil Armstrong said, "Tranquility Base here, the Eagle has landed." And that occurred right here. I'll take you to it. Zoom in. This crater and these two craters are very helpful. As you zoom in, start looking at this crater, and you look up above it about the 11 o'clock position, and you start to see an object that looks like an arrowhead or maybe the letter V. Start to focus in on that. Center it, and you follow it down to about right here to this crater, and about the 9:30, 10 o'clock position of this crater, right here, this little crater, you start to zoom in on that one. And as you get closer, you'll see a little tiny black dot right here, and that is the lower half of the Apollo 11 lunar module. Let's zoom in on it. And you can see it right here casting a shadow on the moon. Neil Armstrong and Buzz Aldrin walked around this area while Michael Collins manned the orbiter that was going to take them home later. The two astronauts ended up spending a total of 21 and a half hours on the surface of the moon, and 2.5 of those hours were spent walking around here. Now here's a photo that has been worked on. You can see the lunar module here. You can see...
That's not good enough for me.
So the thrust of that engine can actually spread out and dissipate away from the engine more than it could
Oh, basically acts like a cushion. Like a hovercraft type of thing, is what she's implying.
on Earth. Instead of the thrust being directed straight downwards, it has a chance to actually billow out to the sides a little bit more. So even though the astronauts are landing with 3,000 pounds of thrust, the force of that thrust is actually dispersed well enough that it disturbed the dust, but didn't leave a massive crater.
It disturbed the dust, so why isn't there a trail?
So while the astronauts landed with about 3,000 pounds of thrust coming out of that descent stage engine, the force was actually spread out enough such that it disturbed the dust, but didn't make a massive crater. And in some cases, the descent stage engine was cut before the actual landing, meaning that the thrust of the rocket engine wouldn't have had as much time or as much proximity to the moon to make any kind of impact. So does this help explain?
No, you're a shill.
My name is Noah Petro. I'm a research scientist here at the Goddard Space Flight Center, and I'm also on the LRO Project Science team. We have some of the most stunning images of the lunar surface that I've ever seen.
9 years ago.
These are pictures of the Apollo 17, Apollo 14, and Apollo 12 landing sites, giving us the clearest view of where the astronauts went, where they sampled, where they conducted scientific experiments on the lunar surface. So these are images that were taken by an instrument called the Lunar Reconnaissance Orbiter Camera. It's an instrument on the LRO mission. When I first took a look at these images, my jaw dropped to the ground. When you see something that you've never seen before, and
So, where's the... I mean, if we can see the damn footprints, I'm sorry, like, thrust would have to, show up on there too, huh?
quality that you've never seen before, it really just made me speechless. For example, at the Apollo 17 landing site, we can see where the lunar rover is parked on the surface. We can see where it drove around the lunar module. You can see the areas where the astronauts kicked up the dust when they walked around. You can see some of the experiments that were left behind sitting on the surface 40 years ago, and you can see where they are, still sitting there on the lunar surface. These are some...
But we can see... And yeah, Curious Joy 4 years ago, huh? Well, granted, they are saying from Earth.
Will I be able to see the flag on the moon? Well, it's a question of resolution. Let me show you what I mean. How many stars can you see? I can see 3, I think. Okay. Now, how many stars can you see?
Oh, there's many more.
Okay, Good. Well, just like our eyes have a limit to how much detail they can resolve at a particular distance, telescopes do too. The flag on the moon is about 3 feet by about 5 feet. So at the distance of the moon, the smallest feature your eye alone can resolve is about 60 miles across. Can you see the flag with just your eyes?
No, definitely not.
Okay. Well, backyard telescopes can generally see about 30 to 60 times more detail than your eye. This scope generally gets 60 times better resolution. So at the distance of the moon, the smallest feature that this telescope could resolve would be about how big?
About a mile?
That's right, yeah. Sure. And how big was the flag?
3 by 5.
Right. So would we be able to see the flag on the moon with this telescope?
No, definitely not.
No, of course not. Now, even a larger telescope such as the Hubble Space Telescope, which is out in space.
They keep on referring to that one, and hold on a second.
Question of whether our telescopes can see the flag or footprints or any other artifacts on the moon. This little activity might help handle that question. We'll use the flashlight and star mask that you just made.
Oh, wow. Image above. Apollo 17 landing site. The top image showcases Hubble Space Telescope's high resolution, ultraviolet, and visible imaging of the Apollo 17 site in the moon's Taurus Littrow Valley. Humans walked and drove on the lunar surface here in December 1972. The X in the top Hubble image pinpoints the Apollo 17 touchdown position. So, what was this? I'm sorry. These observations weren't easy. The moon is a difficult target for Hubble because it moves across the sky faster than Hubble can track it and is very dim in ultraviolet light. The observations require steady, precise, as well as long exposures to search for the resources. Despite these challenges, Hubble was able to image all of its targets, and early results show that the Hubble can detect emanite at the at the Apollo 17 site from 248,000 miles away. And so this was last updated. This is what I was looking for. November 30th, 2007. Oh. So we see why I don't trust the moon landing. Because there's so many people trying to debunk it trying to debunk the debunkers when, I'm just doing this, research.
Perseverance rover has landed on Mars, and now we get to see video of the landing and hear audio recorded on the surface of Mars for the very first time. Space for nearly 7 months, Perseverance landed on Mars on February 18th. In the final minutes before landing, NASA control showed animations of the rover descending through the Martian atmosphere, deploying its parachute, and then finally
Still more real than what actually happened.
Touching down. We even got to see the very first still images taken by Perseverance on the Martian surface. It took some time for video to get beamed back from Mars, but now we've been given a front row seat to see how it all went down, thanks to cameras packed on board.
Notice the dust over there on the right picture. All that dust. I bet you there's a little bit of a wash there. I bet you there is. And this is why I started doing this video in the first place, because the lunar lander didn't even have any dust kicked up or even any debris like that, any wash.
There are actually 23 cameras on board the Perseverance rover. They're designed to do everything from helping with navigation to detecting hazards. There's even a cache cam just to give us a view of rock samples collected from the planet's surface. But among all that hardware, NASA packed in 6 cameras dedicated to recording full-color video of the entry, descent and landing from every possible angle. There were cameras mounted on the protective back shell of the spacecraft, which gave us a view of the parachute during entry. Then there was a camera mounted on the descent stage looking down onto the rover, as well as a camera on the rover looking back up to the descent stage as they parted ways. Finally, a camera mounted on the bottom of the rover captured footage looking down on Mars as the rover landed. All these cameras showed us the entry, descent and landing in amazing detail, from the spacecraft's heat shield dropping away down to the dust blowing on the surface of Mars as the rover descended, and it was one hell of a ride. NASA calls the 7 minutes it takes to go through.
And keep in mind, like this thing's a hell of a lot lighter than a lunar module. I mean, they're not even putting a Jeep with it.
Through the atmosphere and land on Mars, the 7 minutes of terror. Why such a terrifying name? Well, that entry, descent and landing is where a lot of things can go wrong. Think of it this way. After taking off, Perseverance was just terrain relative navigation to capture images of the Martian surface and compare them to maps of Jezero crater to find the best place to land. In the final seconds before touchdown, when Perseverance was about 20 meters above the surface, it did what's known as the sky crane maneuver, where the rover itself was lowered down from the descent stage on a set of cables, getting its legs and wheels ready to land. And then boom, touchdown. Perseverance had landed. The rover had one more surprise in store. Before launch, NASA installed a microphone on Perseverance to capture the sounds of the mission. Sadly, a communication error meant we didn't get any audio of the landing itself, but NASA did manage to capture audio on the surface of the red planet after the rover had landed. You can hear the sound of the rover whirring away, and then in the background, the sound of Martian winds. When NASA tuned out the sounds of the rover, you can hear those winds perfectly, the first sounds recorded on Mars. And the good news is, there's still more footage to come. If everything goes to plan, we'll...
I don't know why it's not telling me in pounds, but hold on a second. So the thing weighed 33,296 pounds. So the moon is 1/6 the gravity of Earth. So that's about how much the lunar module weighed on the moon, about 5,550 pounds.
Soft touchdown on the lunar surface. As such, it's pretty big and powerful. The descent engine had a maximum thrust of 10,500 pounds.
Okay, and so to point, so at the very least, the amount of thrust that's gonna be needed just to keep it hovering is 5,550 pounds. And so that's about half throttle. And coming down, and it probably did have to, maneuver and slow down and stuff too. So, but yeah, 4,000 pounds, it's got to come down. I'm not going to do the math for deceleration and things like that, but 5,500 pounds, that's about where it needs to be to come down gently, because it's 1.6 feet per second that the vehicle is falling down at compared to the Earth.
Sounds like a lot.
And what that means is it's like on Earth, it's 3 meters per second. Or hold on a second. Wait, what's the math there? Okay, well, being that the moon does not have an atmosphere, meaning there is no air resistance, thus there is no terminal velocity. An object falling on the moon will continue to gain speed until hitting the surface. So there is no, this is the same case with objects in space or in a vacuum. No air resistance or drag force equals no terminal velocity. So that's the other thing too, is that the thrusters were basically creating its own little atmosphere in a sense. So the moon surface gravity is about 1/6 as powerful, or about 1.6 meters per second. Moon surface gravity is weaker because of the Earth. So Earth is 9.8 or 53 meters per second. That's like roughly 32 feet. Yeah, this makes more sense. Yeah, we fall at 32 feet per second. And so 1/6 is, that's roughly it. So anyways. Alright, so now we've got 9,850 pounds. Maximum thrust of 9,850 pounds. Well then, did I get that right? 15,000 newtons to 3,372 pounds? That's the ascent. Okay, so 10,000 pounds seems about right for that. This is a really good one. I don't know why. So it looks like there's really no debris in here, but you see the boots, right? Why is that falling?
And it actually really gives you a nice feeling.
Oh, I'll get it back. I'll get it back. Why is that falling? If they're in 0G. Dude, YouTube has deleted my comments. In here. I'm being censored so fucking badly. Alright, so look. Yeah, nothing. I'm surprised I freaking got one of them up here. So there's two. Man, I do that a lot. Friggin', but yeah, why the hell? I can talk about a thing, but I can't talk about things. Yeah, exactly. Donald Trump is not wrong. To piss off, somewhere he's hunting me. My freaking hair. That's a speech that got me in trouble. Paris terrorist tag. Girls clear Pepsi. No mess with a real black woman. What the hell? Did this guy do? Crazy bee. Anyways, hold on.
One by one. First of all, there is that famous videotape that says that, the moon program was a fake from start to finish, and they list many examples. The main examples are not actually the ones you mentioned, but let me tackle all of them. The first main criticism about our going to the moon is the flag. The moon has no air. There's no wind on the moon. We learned that in elementary school. But there are our astronauts saluting a waving flag. You've all seen that picture. It's on many a website. Our astronauts saluting a fluttering American flag. Say the critics, obviously a fake, because flags do not flutter on the moon because there's no wind on the moon. Another thing they say is, look at the shadows. If you look at the shadows, you see not one but two. And the shadows seem to be at different angles. Now, how can you get two sets of shadows unless it's a Hollywood movie set? A Hollywood movie set. Then you have a bunch of lights, and of course the camera crew don't keep track of the shadows, and one of them slipped out, and there it is, our astronauts on the moon with two sets of shadows, obviously Hollywood shadows, nothing to do with a real moonwalk. And you mentioned several others, but let's take them one at a time. First of all, the flag that flutters on the moon is not really a flag at all. It's made out of tinfoil, for God's sake. Look at the video. In one video, you actually see the astronauts putting the flag on the moon, and you clearly see that it's made out of tinfoil. It's solid. It's not a flag at all made out of cloth. So, of course, it doesn't flutter. It's actually bent out of shape precisely to give the illusion that
Where was it? Then the condition of the flags. Here's a sample. And Buzz Aldrin said he saw it in October when they shot up and stuff. And yeah. 11 and 12 did not survive the ignition gases of the lunar liftoff. And then finally on the lunar, scientist Paul Sputis the flag. When you see the shadow of the flag, right? Apparently, is that what this is? Yeah, yeah. And then flag shadow for Apollo 12. You know, but where's the hours after the module lifted off, the Apollo 15 flight was still standing in point as from the 50 degree. So, I don't know. So they were able to capture that. I don't know. I don't. But not the lunar module. It just doesn't make sense, but most people know that the U.S. flags planted on the moon were made of cloth or nylon and were rigged with a wire along the top and bottom. So that's what I'm saying, is that these people are friggin' trying to confuse us. They're deleting our information. They're trying to censor the damn truth. And, yeah. So, try to use this to better figure out. I mean, because, yeah, they've deleted so many of my friggin' comments. They've deleted viewers, subscribers and things. They're holding me down, But, we'll get the truth out there one way, shape, or form. Be safe, be kind, stay strong. I love you all.